Calculus. Increasing and decreasing functions. Find the range of values of x for which the following functions are increasing, and x is an element of the real number set. Our first function is f of x equals x squared minus 2x minus 8, and our second function is f of x equals 2 minus 4x minus x squared. So there are 3 steps involved in finding where a function is increasing or decreasing, and we're specifically looking at increasing functions for this question. So step 1 is going to be differentiate the function. Step 2 will be make the derivative greater than 0. This is what we do if we're interested when the function is increasing. If we're interested when the function was decreasing, we would let the derivative be less than 0. And step 3 is we solve for x. So let's start off with f of x equals x squared minus 2x minus 8. Step 1 is we're going to differentiate. And the derivative of that is going to be 2x minus 2. So when we're trying to differentiate a term, what we have to do is bring the power down in front and reduce the power by 1. So x squared, we're going to bring the 2 down in front to give us 2x and reduce the power by 1. 2 take away 1 will be 1, so it'll be 2x to the power 1, which is just 2x. So we bring down the power in front, the 2 goes in front of the x to give us 2x, and we reduce the power by 1. 2 take away 1 is 1, and x to the power 1 is just going to be x, so the derivative of x squared is going to be 2x. Now we want to differentiate minus 2x. And to differentiate any x term, x to the power 1, we simply just have to cross off the x. So the derivative of minus 2x is just going to be minus 2. So we literally just had to cross out the x. So that gives us minus 2 down here. And then we want to differentiate minus 8, which is a constant. And since when we're differentiating with respect to x, and minus 8 doesn't have an x value, so we just cancel that out. The derivative of minus 8 is just going to be 0, but we don't need to write down plus 0. So the derivative of x squared minus 2x minus 8 is going to be 2x minus 2. So step 1 was to differentiate, that's what we've done there. Step 2 is to make the derivative greater than 0, because we're interested in where it's increasing. So we set 2x minus 2 greater than 0. And step 3 is we just solve for x. So I'm going to bring this minus 2 over the inequality sign, and I get positive 2 on the right hand side. And then I have to divide across by 2 to get rid of that 2. And 2 divided by 2 is going to be 1. So this tells me that x is going to be greater than 1. So what are the range of values of x for which this function is increasing? Well, this function, x squared minus 2x minus 8, is going to be increasing for all x values greater than 1. And I'm going to show you this on a graph in a minute. Okay, so the second function was 2 minus 4x minus x squared. So again, step 1 is we differentiate. And 2 is a constant, so we cannot differentiate that. So we just cancel it out. Minus 4x, we have a x to the power 1 value there. So again, we just cancel out the x, so we end up getting minus 4. So the derivative of minus 4x is going to be minus 4, so that's where that minus 4 comes from there. And then we have to differentiate minus x squared. So again, we bring down the power in front and we reduce the power by 1. Bringing the 2 down in front gives us minus 2. And reducing the power by 1, 2 take away 1 is 1, and x to the power 1 is just x. So we end up with minus 2x. So again, we bring down the power in front to give us minus 2, and then we reduce the power by 1. 2 take away 1 is 1, or x to the power 1 is just going to be x. We get minus 2x. So step 1 is differentiate, and the derivative of 2 minus 4x minus x squared is going to be minus 4 minus 2x. Step 2, make the derivative greater than 0, because we're interested in where it's increasing. So we set minus 4 minus 2x to be greater than 0. Now, what we can do is change the signs of each term, so that because ultimately we want positive x. So if we change this minus 4 to positive 4, this minus 2x to positive 2x, We would have to change the sign of anything on the right hand side, but 0 is just going to be 0 because technically it doesn't have a sign. We must flip the inequality sign so it changes in the other direction. So now we have an equation where we have a positive x value. Now we need to solve for x, so we need to get rid of this 4, so we're going to bring it over the other side and becomes minus 4. And then we need to get rid of this 2, so we're going to have to divide the minus 4 by 2. Minus 4 divided by 2 is going to be minus 2. So we're trying to find the range of values of x for which this function 2 minus 4x minus x squared is increasing, and it's going to be increasing for x values less than minus 2. Now there's another way to solve this, and I'm just going to show you how to do that. So it would have started off the same. Minus 4 minus 2x is greater than 0. And then in the next step, I would have brought the minus 4 over the inequality sign to give minus 2x is greater than positive 4. And then what I would have done was divide it across by minus 2. And 4 divided by minus 2 would have given me minus 2. And at this point, I would have flipped the inequality sign. Because with inequalities, if you multiply or divide by a negative, you have to flip the inequality sign. So either way is fine. It doesn't matter what step you do it in. This is the way that I usually would have done it, but it's no problem if you just want to change the signs across at the very start. Still going to get the same answer. So either way, this function 2 minus 4x minus x squared is increasing for x values less than minus 2. So let's have a look at both of these on a graph. So we found that the function x squared minus 2x minus 8 is increasing for x values greater than 1. So this is my function, x squared minus 2x minus 8, and it's a u-shaped graph because I have a positive x squared. And we found that this function is increasing when x is greater than 1. So let's have a look at where x is equal to 1 on the x-axis, and it's going to be about here. So x is equal to 1 at about this point here. And if I'm to draw a line straight down until I touch my graph, then I can see that I'm actually touching off the minimum point of my graph. And we read a graph in maths just like we would read a book from left to right. And if we're moving from left to right, we can see that our function is decreasing, so it's going downwards, it has a downhill slope, right until it gets to the point of x equals 1, the minimum point of my graph. Then it levels off, so if you had a tangent to this graph at this point, it would have a slope of 0, there would be no slope, so the derivative would be equal to 0. And then we can see as we go past x equals 1, and as our x values get bigger, we can see that our function is actually increasing. It's going uphill, it's going upwards, it has a positive slope. So if there was a tangent to this curve at any point, it would have a positive slope. So it's very obvious to see that our function is decreasing up until the point of x is equal to 1, and then it starts to increase for all x values greater than 1, and this goes on into infinity. But in an exam, we're not always going to have time to actually draw out a graph, so that's why it's important to learn off the steps involved. If we're interested in finding when a function is increasing, step 1, we differentiate. Step 2, we let the derivative be greater than 0 if we're interested in where it's increasing. We let the derivative be less than 0 if we're interested in where it's decreasing. And then we solve for x. So when we solved, we found that the graph is increasing at x values greater than 1. And we can clearly see that at x is equal to 1, our graph starts to increase. Likewise, for our second function, 2 minus 4x minus x squared, if we were to draw out that graph, we can see it's an n-shaped graph because we have a negative x squared value. When we did step 1, 2, and 3, we solved for x and we found that x was less than minus 2 when it's increasing. So again, I'm going to go to minus 2 on my x-axis. I'm going to draw a line straight up until I touch my graph. And I can see that at x is equal to minus 2, I've actually ended up touching off the maximum point of my graph. This is where my graph turns. And it's very obvious to see that the graph is increasing for x values less than minus 2. At x equals minus 2, my graph would level off. So if I had a tangent to this graph, it would have a slope of 0 or a derivative equal to 0. And then I can see that it starts to decrease, it starts to go downhill then for any value, any x values above minus 2. So when we did step 1, 2, and 3, we solved for x in step 3 and found that x was less than minus 2 when our graph was increasing. And it's very obvious to see that that is true, that our graph is increasing, it's going upwards, or it's going uphill, right up until we get to minus 2 on our x-axis.